welcome to another Spark Revised video. Today we're going to be looking at binary basics for GCSE Computer Science. This is presented by Spark Revised. Please check out our channel, got loads of other videos and loads of more in-depth binary videos, including on our shorts page, so go and check all that out. While you're at it, drop us a subscription, like and comment any ideas you've got for future videos. This is binary basics. This is aimed at OCR GCSE Computer Science, but will be applicable to all exam boards, and it is a great way to build a foundation of binary knowledge or to refresh your knowledge before an exam. So let's get into the video. So computers are everywhere, your phone, your car, or even your fridge. But have you ever wondered how they actually store numbers? Because they don't use our normal counting system. Instead, they use something called binary. In this video, we're going to break down binary numbers step by step. You'll learn how to convert numbers between binary and denary, how to add binary numbers together, and even how binary shifts work. By the end, you'll understand exactly how computers handle numbers. First, let's talk about the difference between our normal number system, known as denary, and binary. We normally count using base 10. This is the numbers 0 to 9. There's 10 of them. In base 10, each column of a number is worth 10 times more than the one before it. So we've got a number, e.g. 235. This is the ones column. This is the tens. This is the hundreds. Each column is worth 10 times more than the one before it. But in binary, there are only two digits, 0 and 1. This means each column of a binary table is worth 2 times more than the one before it. So let's look at an example. This is an example 4-bit binary conversion table, and as you can see, each number is double the number it comes before. Let's look at the basics on how to use a binary conversion table. Take the denary number 13. To convert 13 into binary, the first thing we need to do is see, does 8 go into 13? Yes, it does. So we put a 1 in the box here. What is the remainder of 13 minus 8? 5. That's our remainder. You don't have to put it up there, keep it in your head. Does 4 go into 5? Yes. So we put a 1 here. What's the remainder? 1. Does 2 go into 1? No. Put a 0. Does 1 go into 1? Yes. Put a 1. And as you can see at the end, there should always be no remainder left. So therefore, 13 in binary is 1, 1, 0, 1. You've done your first binary conversion. Next, let's look at an 8-bit binary conversion. We're going to convert the number 131 into binary. Please, if you know what you're doing or you want to give it a go, pause the video, have a go, and then come back and watch my solution. So, if everybody's stuck around or everybody's coming back, this is the solution. It's a nice easy one. So, does 128 divide into 131? Yes. We're going to pop a 1. What's the remainder? There is 3 remaining. Does 64 go into 3? No. Does 32 go into 3? No. 16 into 3? No. Does 8 go into 3? No. Does 4 go into 3? No. Does 2 go into 3? Yes. Does 1 go into... What's the remainder of 2 and 3? 1. Does 1 go into 1? Yes. So, equals 1, 0, 0, 0, 0, 0, 1, 1. And there is your answer. So you've now done 2 denary to binary conversions. So let's look at binary to denary conversion. Once again, with all these conversions, there's loads of other videos out there on our page, on our shorts page, so go and check them out. Now, to convert binary back to denary, we just add up the values where there are ones. So, if we've got the binary number 1, 0, 1, 1, 0, 1, 1, 0, we're going to then convert that into denary. Again, if you know what you're doing, pause this, test yourself, and come back. But for everybody stuck around, we're going to pop this into the conversion table. 1, 0, 1, 1, 0, 1, 1, 0. And we're going to add up the numbers where there are ones. So 128 plus 32 plus 16 plus 4 plus 2. So 128 plus 32, well, that is 160 plus 16 plus 4 is 20 plus 2 is 22, which equals 182. and we've done our very first binary to denary conversion. Now that we know how to convert numbers, let's talk about binary addition. So it works exactly the same as normal addition, except you only have zeros and ones. There are 4 rules of binary addition. And as soon as you know these 4 rules, you are completely, perfectly going to be able to do binary addition. So here are the 4 basic rules. 0 plus 0 equals 0. 0 plus 1 equals 1. 1 plus 0 equals 1. 1 plus 1 equals 1. 0, which is 0 carry 1. And this might seem like absolute gobbledygook to anybody who's not done this before, but I promise you with these 4 rules you can add any 2 binary numbers together. Let's put it into practice. Let's add these 2 numbers together. So 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. And here's where it gets difficult. 1 plus 1 is 0 carry 1. So we're going to put a 0 there, and we're going to carry the 1. You can carry above, below, doesn't really matter. Now we've got 0 plus 1 plus 1. So firstly we do this bit. 0 plus 1 is 1. So then we've got that results in a 1. So we've got 1 plus the 1 from down here, which is 0 carry 1. Same again. That gives you 1. This is 1. 1 plus 1 is 0 carry 1. That gives you 0. That's a 1. 0 plus 1 is 1. So the addition gives you 1, 0, 0, 0, 1, 1, 1, 1. And that is your first binary addition. Hope that makes enough sense. Once again, check out our other videos on that. And we'll move on to the next stage. We're going to do one more addition, and it's going to be something a bit different this time, which we will then explain. So, once again, let's do this addition and see what we get. 0 plus 0 is 0. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1, remember, 0 carry 1. 1 plus 0 gives you 1, plus the 1 gives you 0 carry 1. Oh no, we've exceeded the 8 bits of our number, because this is 100 plus 200, 100 plus 200. So it's given us 300, which is out of the range that can be stored in an 8-bit binary number. So we've got this overflow bit. This is called the overflow error. Sometimes when we're adding, you get a result that needs more than 8 bits. This is called an overflow error because the result is too big to store in a single byte, which is 8 bits. This can be a real problem in computing. It can cause incorrect calculation or even program crashes. For GCSE, all you need to know is understand what an overflow error is, recognise when an overflow error occurs, when you've exceeded the maximum size of a number that can be stored in 8 bits, explain what the effects are, program crashes, incorrect calculations, and describe how computers will handle overflow errors, which we'll go into more detail in a different video. The most important thing is not to stress about it when you see an overflow error. A lot of the time at GCSE, they just want to see your 8-bit number, and it will probably say, show it as an 8-bit, add these 2 numbers together, giving an 8-bit binary number, in which case you discard the overflow, unless it specifically says as a 9-bit binary number or specifically asks for the overflow. Do not need to include the overflow. But again, check with your teachers, check with your specification for what is best to do here. But it's nothing to panic about. If in doubt, put it in a little set of brackets there. So that's an overflow error. Nice and simple. And that is binary addition completed. So thank you so much for watching. Drop a like, comment and subscribe for more. We'll get loads more videos on the way to you.